In this video, we're going to be taking a look at modeling and writing expressions. You'll need to have your Go Math book turned to page 261, your math journal, and a pencil. Now, the essential question for today's lesson is how can you model and write algebraic expressions? So let's take a look at a few key terms that we'll be talking about today. So writing algebraic expressions, first of all, it's important to know an algebraic expression is an expression that contains one or more variables, and a variable is represented by a letter. So we can see what I mean by a variable. So x would be a variable, w, n, y, it's representing a number. So one or more variables, and may also contain operation symbols such as plus or minus. A variable, like I talked about a little bit earlier, is a letter or symbol used to represent an unknown or unspecified number. The value of a variable may change, so it's not like a always equals 1 or anything like that. It all depends upon the algebraic expression you're looking at. A constant is a specific number whose value does not change. In other words, think about it as this problem, 150, is constantly going to be 150. And in the problem here, 150 plus y, y is a variable. So those three things are very important to understand. Also, an algebraic expression, multiplication and division, are usually written without the symbols x, or the multiplication symbol, and the division sign. So if I'm taking a look at write 3 times n, you can write it as 3n. Whenever there is a number and a variable right next to each other without any operation symbol, it's always understood that it's multiplication. So you can even see the dot there, 3 times n, or n times 3. That dot can also mean multiplication as well. 3 divided by n, you can see it written as a fraction, 3 over n. Now, a couple other things. There are several different ways to describe expressions with words. So addition, you can see all the words that would go along with addition, subtraction, multiplication, and division. So it's important to think through this as we are writing phrases for expressions as well. So let's take a look at example number 1. It says write each phrase as an algebraic expression. So we're taking a look at this. It says the sum of x and y. So as we're continuing to think through this and learn through this, we know sum means addition. So the sum of 7 and x, we could see the operation is addition, and the algebraic expression is 7 plus x. Remember, algebraic expression, we have a constant, we have an operation, we have a variable. So the quotient of 7 and 3. So we know quotient is the answer in a division problem. And so the algebraic expression, remember, you don't, they're usually written without the division symbol. So we have the algebraic expression is 7 divided by 3, written as a fraction. Let's take a look at letter B. It says write a phrase for each expression. We have 11 with a variable x right next to it. Just remember that whenever there's a constant and also a variable right next to each other without any type of operation, it's always understood to be multiplication. So the operation is multiplication. We could say the phrase is the product of 11 and x. So you can see we're not just saying 11 times x. We are saying the product of 11 and x. We're taking a look at those different ways to describe expressions with words and so on, and we're using those. Next one, we have 8 minus y, so we know the operation is subtraction. So we have y less than 8 for the phrase. So let's take a look at number 1. So it says write each phrase as an algebraic expression. So we have n times 7. Okay, so let's do this together. So we know we have our variable, and then we're just going to write 7 right next to it, representing multiplication. The next one, we have 4 minus y. We can just write 4 minus y. Pretty easy there. 13 added to x. So for this, do not think that it's always just going to be in order 13 plus x, okay, because that would be x added to 13. We're going to add 13 to x, so we're going to have x plus 13 for that algebraic expression. Now let's take a look at the phrases for numbers 4, 5, and 6. We have x divided by 12, and we are going to write it this way. We have the quotient of x and 12. Quotient because that's a term for the answer in a division problem. Next one, we have x times y. And for the phrase, we could write 10 multiplied by y. Next one, c plus 3. We can easily write c plus 3 there for the phrase. So we've taken a look at how to write algebraic expressions and then how to write phrases for them. Now what we're going to do, we're going to see how algebraic expressions can also be represented with models, so you can really see it for yourself and what different things represent. It says for letter A, use a bar model to represent each expression. So we have 7 plus x. Okay, so we're thinking about the whole entire problem represents 7 plus x. So we can see that section here representing 7 plus x. So what we need to do, we can take this bar, we can divide it up into 7 pieces. Why 7 pieces? Because we have 7. And then from here, we can represent the x. In other words, what's left over after the 7 pieces. And you're adding those together, representing the algebraic expression 7 plus x. Now the next one, we have divide z into 3 equal parts, or z divided by 3. So the whole entire model represents z. And what we can see here is we divided z into 3 equal parts, so z divided by 3, the answer to z divided by 3 would be this 1 bar right here. We don't know what the variables represent or anything like that. We're just looking at how to model, using a model to represent these expressions. So we're not, with any of these, we are not trying to find the answer. We're just writing the phrases, and we are trying to figure out how to write out the algebraic expressions. So let's take a look at number 7 together. I want you to write this out with me. It says t minus 2. So we can see, representing this as a model, the whole entire bar would represent t. And we can see 2 of the sections represent 2, so you're taking 2 of those sections away for t minus 2. Next one. We have 4 times y. The whole entire model represents the algebraic expression, and then underneath we divided that bar into 4 parts. Why 4 parts? It's because we're multiplying y times 4, so y represents one of those parts. So you can see how the different parts of that algebraic expression can be represented within the model. Now let's take a look at example number 3. Before we take a look at that, let's look at comparing expressions using models. It says algebraic expressions are equivalent if they are equal for all values of the variable. For example, x plus 2 and x plus 1 are equivalent. So let's take a look at example 3. It says Katrina and Andrew start the day with the same amount of money. Katrina spent $5 on lunch, Andrew spent $3 on lunch, and $2 on a snack after school. Do Katrina and Andrew have the same amount of money left? What we're going to do is we're going to write an algebraic expression to represent the money Katrina has left. We're going to represent the expression with a model. So we can see The algebraic expression is x minus 5. And why is it x minus 5? Because we can see that the variable represents the amount of money both Katrina and Andrew have at the beginning of the day. So we don't know how much they have at the beginning of the day, so we're going to use a variable x. Why is it subtraction? Because she spent money. How much money did she spend? She spent $5. Okay, so we have x minus y. Now if we're taking a look at a model, we have x, which is the variable representing the whole entire bar, and we can take 5 away from this bar. Okay, why 5? Because she spent $5. Then the remaining of this model would represent what would be left over, the answer. X minus 5 would be the remaining of this. Now let's take a look at step 2. We can take a look at writing an algebraic expression to represent the money Andrew has left. Represent the expression with a model. So we have X, the amount of money that Andrew started with, minus 3. Why minus 3? Because Andrew spent $3 on lunch, and then minus 2 because he spent $2 on a snack. So x minus 3 minus 2. Now we can take a look at this model. X represents all the money that Andrew has. Take 3 away. Take 2 away because he spent $3 on lunch and $2 on a snack. And then the remainder of this model represents x minus 3 minus 2. Now let's take a look at the models, see if they are equivalent. And the models are equivalent, so the expressions are equivalent. Andrew and Katrina have the same amount of money left for step 3. Okay, so let's take a look at number 9. We'll do this together, and I want you to write this out on page 264 with me. It says, on a math quiz, Tina scored 3 points more than Julia. Juan scored 2 more points than Julia and earned 2 points in extra credit. Write an algebraic expression and draw a bar model to represent Tina's score and Juan's score. Did Tina and Juan make the same grade on the quiz? And also we can explain this. So I'm going to show you the different models and how you can break these down. So I know that the whole entire model is going for Tina. So we know that Tina scored 3 more points than Julia. So we don't know how many points Julia scored. We just know that y can represent the amount of points Julia had, and then 3 more points. Okay, so y plus 3. So we have y representing however many points Julia had. We don't know, so that's why we use a variable. And then we can add 3 points because she scored 3 more points. Now let's take a look at Juan. Juan scored 2 more points than Julia. So Julia's score, once again, is represented by the variable y. 2 more points, so y plus 2. And then he earned 2 more points in extra credit plus another 2. So the y in the bar model would represent Julia's score again, plus 2 more points than Julia, plus 2 points more in extra credit. So we can take a look at that as the bar model. Now we need to look at the expressions and see if they are equivalent. Y plus 3 and then y plus 2 plus 2. If you were even to add the 2 plus 2, it would represent y plus 4. Comparing to y plus 3, we can see that the expressions are not equivalent. Now let's jump down to modeling real-world situations. It says you can use expressions to represent real-world situations. So let's take a look at example 4, letter A. It says tickets to the water park cost $53 per person. Write an expression to show the total cost of tickets for a group of people. So we can see a group is a clue to multiply. And the ticket price of $53 is the constant. In other words, it's not going to change. And the number of people who need the tickets is a variable. Okay, for example, there could be a family of 8 going, or then a family of 3, and then a family of 5. Depends on who's going, so that would be a variable. And we can use x for the number of people. We can just choose a variable. It doesn't mean that x always has to represent the number of people or anything like that. So we can take x Using that as a variable, we can write 53 because that's the cost. So x times 53 would be our algebraic expression. We don't have to solve it, that's just the algebraic expression. And remember, whenever you have a variable and a number right next to each other, that always means multiplication. You don't have to write a multiplication sign or anything like that. Next one, Janice has some savings. After babysitting, she adds $75 to her savings. How much money has she saved? So we have, for this, add is a clue to use addition. Okay, so we can see add $75. $75 is Janice's. She added to her savings as the constant. The amount of money she had saved before is unknown, so that is going to be a variable. So we could choose any letter to represent that variable. The book chose Y, so we have Y, that's the amount of money she had, which we don't know, and plus 75. Why is it plus 75? Because that's how much she added to her savings. Now what I would like you to do is read number 10, and you can work on that all by yourself, and you can work on that now. So you can see the answer for number 10 is D divided by 4. Now I'd like you to take a look at page 265, and you can work on number 1, and you can work on that now. Okay, so the answer should be Y minus 3. Now I want you to take a look at number 4, and you can work on that now. So the answer for number 4 is 10 divided into P. You might have something a little bit different, but as long as it represents that. Now I want you to take a look at number 6, and you can work on that now. So you can see the bar model that is represented, and also the variable that would be represented with each of these, which does answer number 7. Are the expressions equivalent? No, they're not equivalent. So let's take a look at jumping down to number 9, the essential question check-in to wrap up the video. It says, give an example of a real-world situation that could be represented by an algebraic expression. And you can see it says you earned $15 on Monday and will earn more money tomorrow. 15 plus D, where D is the money you earn tomorrow, represents your earnings for the 2 days. So that's just an example of an algebraic, a real-world situation that could be represented by an algebraic expression. So this concludes the video on modeling and writing expressions. If you have any questions about this concept, please come and see me.